All right, hello. This is a new Elmo for me, team, so give me a second to get it together. Oh my gosh, I hate this Elmo. That's zooming out. Okay, great. Hi. We're good now. Hello. We are finding the midpoint of a segment on the coordinate plane in this lesson. Let's start with our important vocab. So first, what is midpoint? That is the point that's in the middle. Okay. We can use congruency marks to show that. So if I've got a segment here and I place M in the middle, I can do these congruency marks to show that that point is really in the middle because these two segments then are on the same length. Okay. This lesson will also need coordinate plane. So here's our coordinate plane, x-axis, y-axis. Let's also put that this is positive, positive, negative, negative. A coordinate point is a point on the coordinate plane. So, I don't know, let's plot 2, -1. So that's 2 to the right, down 1. So that would be about there-ish. And remember, the first number is your distance on the x-axis, and then your second number is the distance on the y-axis. A compass, we're going to use that in today's lesson. I remember it is never eat soggy waffles. Okay, those helps us show direction. Average. So we're going to use averages today. An average is the center of a set. And how we compute it is, let's say I'm doing like 2 plus 3 plus 4. And I want to find the average. I add the numbers and then I divide by the amount of numbers there are. So 2, 3, 4, there's 3 data points there, so I'm dividing by 3, so 3, 4, 5, you get 9 divided by 3, and so the average of those 3 numbers is 3. Okay, the formula is like this. Area equals length times width. That is the formula for the area of a rectangle. So it's an expression that like gives us a desired result, helps us calculate a desired result, okay? So in class, we started talking about kind of monkey in the middle and midpoint. We're going to jump straight to the key points box and talk about first midpoint on the number line. Okay, so let's look at example 1 to start. It says the endpoints of A, B on the real number line are at -3, 5. Where is the midpoint of M? So I'm reading endpoints are at -3, 5. Where is the midpoint M? Okay, so there's a few ways I can find this. First, if I draw this out, and I think, okay, -3, 5. So those are my endpoints, A and B. And I think about the middle. So how far is it from -3 to 5? That is 8 units. So if I divide 8 by 2, I'll see that there's 4 units in between each of these. So if I count 4 units from each endpoint. So -3 to 1 is 4, 1 to 4, 1 to 5 is 4, and the spot that gets me there is 1. So this idea of the distance from the midpoint to endpoint will always be the same. And you could have just counted that out. Or if we call our endpoints x1 and x2, we're really on an x-axis here, we're just on like a flat number line, then we can calculate the midpoint, we'll call it M, by taking that average. We can do x1 plus x2 divided by 2 will give us the midpoint. So what I could have done here is taken my endpoints, -3 plus 5 divided by 2, and then -3 plus 5 is 2 over 2 equals 1. So that's another way of finding the midpoint. Okay? Example 2 says the coordinate of G on GH on the real number line is at 6. If the midpoint M is at -1, where is H? So this situation is different because I'm given an endpoint and a midpoint, and I'm finding the other endpoints. I'm going to actually draw this out a little more carefully for us so we can see about counting it, okay? So It says G is at 6. The midpoint's at -1. So I'm going to count 6, 5, 4, 3, 2, 1, 0. -1 would be right there. So this is my M. And this is my G. Now, how far away are those? I kind of did this quickly up here, but if you need to actually count 1, 2, 3, 4, 5, 6, 7 is the units there. So then I gotta go 1, 2, 3, 4, 5, 6, 7 over here. Where does that land me if I go the 7 this way? I think -1 minus 7 more is gonna get me to -8. And that's gonna be where H is. So that's where I could use a picture to like figure that out. Okay. I could also use this formula kind of backwards, where I think to myself, okay, I'm given an endpoint G, which was at 6, plus I don't know the other endpoint, so let's call it x2. But I know if I divide those by 2, it'll give me my midpoint, which was -1. Okay, so I could set up that equation and solve it. To solve, I multiply by 2 to cancel out the dividing by 2. And then that leaves me with 6 plus x2 equals -2, divided by, or -2 minus 2, and you're going to get x2 equals -8. So that's like another way of seeing it. Okay? I'm going to jump to our next key points box. So next what we're going to deal with is what if we have midpoint now on the coordinate plane? So instead of a flat segment where we're trying to find the midpoint, now we've got this diagonal segment where we're dealing with x's and y axes. Okay? So now that will mean that the endpoints of the segment are going to now be x1, y1 and x2, y2. Not just x1, x2 and y1, y2. It's going to be the combination of both. Well then, the midpoint, M, we call M, is going to be equal to finding the middle on the x-axis and finding the middle on the y-axis. Basically, I'm finding the average of both the x and the y, and I'll kind of point that out. I can show that graphically over here, okay? So if I'm finding the midpoint from the segment shown, so if I think about, okay, what's the distance on the, from here to here on the x-axis? It's 1, 2, 3, 4, 5, 6, 7, 8, right? So half of that, 1, 2, 3, 4, is going to be like here, okay? So I know that my x value is going to be 1 because halfway on the x-axis lands me at 1. Then if I count, well, how far is it as I go up? So let me go from here to here. So 1, 2, 3, 4, 5, 6. So that's 6. That means 1, 2, 3 here. So it's going to be at 2. Combination of those two spots is that spot right there. Okay? So what you might notice here is the slope. The slope from each endpoint to the midpoint will be the same. So basically if I count 1, 2, 3, 4 to the right, and then I count 1, 2, 3 up, right? Again, it's another 1, 2, 3, 4 to the right, and then 3 up. So I basically kind of divided that original slope in half, okay? How I could do that using this formula is if I take my endpoints, which are at what? -3, -1. And then what is this endpoint? This is at 5, 5. I'm going to code them. So this is my x1. That's my x2. This is my y1. This is my y2. Midpoint is going to be equal to me finding the average of both the x's and the y's. So I can add -3 plus 5 divided by 2. That gives me negative 3 plus 5 is 2 divided by 2 is 1. Okay? And then we do the same thing for the y's. Negative 1 plus 5. Negative 1 plus 5 divided by 2. That's 5 and negative 1 is 4 divided by 2 is 2. So, a different way of finding the same thing. I found 1, 2 by like counting over here, or I could do it using the formula. Okay? So you get to pick which way makes sense for you. Okay? Last thing I'm going to show you is finding endpoints on the coordinate plane. So, same idea. Some hints I'll give you is that if we're, well actually let me graph this out and then I'll give you these hints, okay? So it says find the endpoint of AB. So I'm looking for an endpoint. Given its midpoint M is at 2, 1, and A is at 4, 3. Okay, so let me plot this out. So A is at 4, 3. So 4 to the right, up 3. That's A. My midpoint is at 2, 1. So that's M. So my segment kind of looks like this. So my other endpoint is going to be somewhat over here. Now, if we use this idea of the slope, from each endpoint to midpoint will be the same. Let's do that idea. So the slope is, I go 2 to the left, and then I go 2 down, right? So if I go 2 to the left, and then 2 down, that shows me exactly where B needs to be. Which is at what, 0, negative 1? Okay, so it's one way to use it. Or you could use that midpoint formula and solve for x1 and y, or actually x2 and y2. Okay, so I'll show what that looks like over here. So if we've got our midpoint formula, I'm going to kind of break this into two ideas, okay? So this is me solving for x2. I know, so here, we have the midpoint is at 2, 1. So for the x coordinate, my midpoint is 2. That's equal to dividing or adding 4 plus whatever our x2 value is that we didn't know yet. Right, so I had A over here, which was 4, 3, and that's x1 and x2, or sorry, x1 and y1. Okay, and so now I just like kind of set up this formula and then I solve it. So I'm going to solve, I'm going to multiply by 2 on both sides, get 4 equals 4 plus x2, subtract 4, and it gets me x2 equals 0. Which checks out from the graph I did here. Okay, and then now let's solve for y2. So let's use the formula. So I know my y-coordinate for the midpoint is 1. So 1 is equal to my y1 value, which was 3, plus whatever y2 is divided by 2. And then I can just solve this formula. So multiply by 2 on both sides. You get 2 equals 3 plus y2. Subtract, and you get y2 equals negative 1. Okay? Which checks out when I graphed it over here. Okay? It might help if when we're doing this, I coded A as x1 and y1. You might also want to code before you even start that the midpoint is 2, 1, and that this is your x value and that's your y value of your midpoint. So it helps you figure out where to like plug this stuff into the formula. I'm gonna do some color coding quick so you can see what I did. So x1 was here, right? And then the x value for the midpoint went there. And then y1 was here, and then the y value for the midpoint was there. You're going to see how I'm plugging stuff into the formula. Okay? And that's it. Hope that made sense.